How can we solve our routing loop? We can solve our routing loop by implementing route tagging. What is route tagging? Well, have you ever watched the Wilderness Channel or something similar to the Wilderness Channel? What do they do sometimes? They go out, they capture animals, they tag them, they weigh them, they measure them, and then a couple of years later they find them again, and then they can verify their new statistics to the old statistics by comparing the information that was in their database simply by referring to the animal by this tag they gave it. Well, the same thing is true here. We can tag routes so that way there we can perform other services or features on that route later on in the network just by calling upon that particular route tag that we set. So in this example, what we need to do is we need to set a tag on those default routes as they're being redistributed. How do we do that? Set up a prefix list. Define the default route in that prefix list. And then create a route map. In that route map, match the default route and set the tag. So in this case, we're setting the tag to 40. It's just an arbitrary number we came up with. And then from there, we can perform an action on that particular tag. Notice over here that we've set the tag on the redistribute command. So redistribute EIGRP 100 route map set tag. And that's what's happening on R1 as we redistribute into the OSPF domain. We're setting the tag to 40 for the default route. Everything else is not getting a tag of 40. That's why we have this open one right here. So redistribute everything else, but don't tag it. Now I want to go way down to R4. And I want you to notice that route map deny 10 says match tag 40. But how is that being applied? It's being applied to this distribute list here. You see the distribute list? It says deny tag in. So as 40 comes in, we are filtering it with a distribute list. We are saying do not install in the OSPF routing table any route with a tag of 40. So that ensures that this default route that's learned via EIGRP with an administrative distance of 170 stays in the routing table because we are denying entry into the routing table from OSPF. That's what we're doing. So by preventing the OSPF route from being installed in the routing table, we allow the EIGRP route to stay in the routing table. And then we do the same thing in reverse. So on R4, we are calling upon that particular default route in what? In a prefix list. We're applying it to a route map. We're setting a tag on that route map to 20. And we can see it right there. Redistribute EIGRP 100 route map set tag being applied. So that's being sent out with a tag of 20, the default route. And then as it comes back around, we filter it on R1. And if you examine R1's configuration, deny tag, right here, deny, match tag 20. And it says distribute list route map denied tag in. So this ensures that we do not install the default route from OSPF in R1's routing table, ensuring that the default route from EIGRP with the higher administrative distance stays in the routing table. So this is one method, using tags to filter the traffic and ensure that the loops are prevented. You could also just modify administrative distance if you felt like it. You could say any particular EIGRP route or any particular OSPF route on this particular router should have an administrative distance of this. So you could modify that if you wanted to, and as a result, you could ensure that the R1 routing table maintains that EIGRP external route, and the R4 routing table maintains the EIGRP external route as well. So the problem here was related strictly to administrative distance. OSPF was being preferred because it had the lower administrative distance, and since we have multiple points of redistribution, it was causing a routing loop.